All right, welcome to episode 3 of season 5 of live.withcode.uk. In this season, we are looking at not just how to get more confident at using turtle graphics for drawing, but we're also practicing some of the harder aspects of GCSE computer science for the Edexcel on-screen test. So last week, we got as far as displaying a two-dimensional image from a two-dimensional list, where 0 represents a black pixel and 1 represents a white pixel. This week, we're going to move on a stage to go to a grayscale image. So I've downloaded an image that I found online, put it through tools.withcode.uk/bitmap, changed the settings to make it a grayscale image rather than black and white, so that when we look at the bitmap data, we have numbers between 255, that's white, and I don't think there are any black pixels here, but if there were, they would be represented as zeros. So I'll copy that data, not the Python, it's just the raw numbers here, the integers. Let's put it into a new file, call it image data.txt, paste it in, and then let's start coding. So I want to be able to load the data from a file and then display the image data, or just display the image. So what can we do? I want to be able to do something like this, load from file. What did we call the image file? It was image data.txt. That looks like a value that we should give a name, which sounds like a constant. There we go. So we'll put a constant in here. This will return the image data, which we want to store and use. So pixel data is going to be the return value. When we run it, Python doesn't know how to load from a file yet. Well, obviously, we haven't told it how to. So let's define load from file. We've passed in one argument. So the function receives one parameter, which describes the name of the file to load. And it should return some pixel data. What is data? Well, it's going to be a list of lists of integers, a two-dimensional data structure. All right, no problems yet. Once we've loaded it, and obviously we haven't done this yet, we need to display it. So I want to be able to do something like display image pixel data. So we're passing in that data. This is a procedure rather than a function. It doesn't need to return anything, but we do need to tell Python how to display an image. Right, display image p data. Remember Python, sorry, not Python, Edexcel likes you to preface all of your parameter names with a p, just so that we're clear that it is a parameter. It's not necessary in Python, but it's what you'll see in the on-screen exam. How are we going to do this? Well, we're going to use a variable called y to go from 0 up to 32, but that value 32 I'm going to give a name and say that that is the height of the image. I'm going to assume it's always 32 because that's the height and width of all the images that are processed using this online tool. And then the same for y in range, but this time I'm going to call it width. Sorry, it should be x, shouldn't it? There we go. So the width is also going to be 32. Right, how do we access the actual pixel value? So that will be p data. First of all, we need to know what row, as in how far down. So that's row 0, that's row 1, that's row 2, row 3, row 4. So that's y. And then another indexing expression to work out how far across, as in that is column 0, column 1, column 2, column 3. Right, so if this is the value, what do we do with it? Well, this is an integer. I need to convert that into a hex color and display it. So let's try and work out the hex color code needs to be convert to hex color. There we go. Doesn't know how to do that yet. We need to define that function. Why is it a function? Because it returns a value that we're going to store later so that we can draw something, do something with it. Def convert to hex color. We have a p integer, which is a grayscale integer from 0 to 255. Now, to do this, we're going to use string formatting. We know that, let's have a look, HTML color picker. What do I mean by HTML colors? Well, you can have any color on here. What we want is something like this: a hash, 2 digits for red in hex, 2 digits for green in hex, and 2 digits for blue in hex. And if it's grayscale, then all of the digits are going to be the same. For example, here, 217, 217, 217, same amount of red, green, and blue, means we get a shade of grey, and then all of the hex digits are the same. How on earth can we do that? Well, string formatting means we can have the same number 3 times. We can pad it to 2 places, but not 2 decimal places. This is not in the PLS. This is something new this time. But we can convert it to hexadecimal, so that you won't be expected to do that on your on-screen exam. It's just a nice little extra cheat that's not in the PLS. Layout.format. Okay, I want a value for this, which is just the grayscale integer, as in how bright it is. So let's just call it brightness, which I think makes more sense. And I'm going to pass that same value 3 times. All right. This is the value that I want to return. So will it work? Well, not yet, because we haven't loaded anything in. So for now, let's just comment this and test it. Oh, I hope it's going to work. Let's see. So if we print, what have I called it? Convert to hex color. If I pass in 255, I'm hoping I'll get a hash and then 6 Fs, because that's red, green, and blue switched on. If I go for 0, I'm hoping it'll be black. Not great, because that didn't work. And that is sad. We'll have to implement it a slightly different way. So how can we do this? I mean, that would work, but not... Oh no, it would work actually. I think it would probably be okay, because, yeah, no, we'll stick with that. I think the color codes would cope if it's just 3 values or if it's 6 values. It might get confused if we have different values of red, green, and blue, but that's not going to be a problem for us in this program. All right, back to actually implementing this bit here. This is now inside this bit because pdata is empty, because we're not actually loading it from a file. Right, let's load it from a file. Let's open the file name. If we open it, we mustn't forget to close it. Lovely. Then we want to read all of the data from that file, and I'm going to call that contents because it's going to store the entire contents of the file. Next, we split the whole contents of the file into a one-dimensional list so that we can get all of the lines separately. And then we can iterate through each line, for line in line. So lines is a list of all of the lines. Line is an individual line. And we can split that this time based on whenever we come across a space. This is not a comma-separated value file. It's separated by spaces. Where am I up to? I'm confused. Here we go, separate by space. This is going to be the pixels. However, this will be a list of strings rather than a list of integers. So I guess we want to go through for pixel in pixels, convert the pixel into an integer, and then do something with it. What are we going to do with it? Well, let's see. We'll make a one-dimensional data structure for each row of pixels. That's what we can add, append our integer value to. And then after we've gone through each pixel, we can add in our row to our two-dimensional data structure. Okay, almost works here. However, at the end of each line, we've got like an empty space. So I only really want to do this if the length of pixel is more than 0, as in it's not an empty string. All right, no problems yet. It seems to load from a file. It doesn't display anything yet because, well, we haven't told it to. So what do we want to do? I'm going to use round pixels this time. So I want to do t.circle, but let's see, t.pen up to teleport to the right place. That would be x and y. No, you can't do that. Let's just lift up the pen and then go to x and y. There we go. T.pen down. Then we can set the color. T.color spelled the American way because it's built into the Turtle Graphics module. Set it to the color we've just calculated. Draw the circle. Well, yes, but I want to fill it in. So t.begin fill. After we've drawn it, we can do t.end fill. And it will almost work. However, it will go horribly slowly, and it doesn't know what t is yet. So we should say t equals turtle dot, make a new turtle object. T.speed help to go as fast as we possibly can. Doesn't know what turtle is because we haven't even imported it yet. Strictly speaking, we should say turtle is going to be, how do we have an empty object? There we go. So it's running, but is it actually going anywhere? It doesn't look like it is. Let's try again. Now here, each pixel that we draw is not just going to be one dot on the screen. I'm going to say it's going to be 5 pixels in size. So pixel size, will this work? Don't know. Let's see. Does the turtle move across? Doesn't seem to. Does it display anything at the end? Like, does it get to the end here? Or does it get stuck? Seems to get stuck. Why is this? Let's just print the pixel. Help, what's going on? Are we loading in the data properly? Looks like we are. We have a 2-dimensional data structure. That all looks good. So for y in range, for x in range, we should be drawing t.color. I wonder why this isn't working. Let's see. Why is that turtle not moving across? Do not know. I think it's because I've forgotten to convert each of the values into hexadecimal. There we go, we've got valid color codes, but we don't seem to be actually drawing any pixels, or are we? Is it just because we're drawing lots and lots of white ones? Maybe if I put a 100 in there just for testing. I don't want to display all of these here, that was just for testing. Yeah, it has moved, and we can't see it. Looking promising. But it's not in the right place. So how about we say 200 minus all of this to flip it the right way up. Still can't see anything. And 200 minus all of this, or no, all of this minus 200. Come on, where are these pixels? I'm hoping that in about 10 seconds or so we'll start to see the pixel values. Will it work? I'm going to give it another 20 seconds. Oh, I did see a little turtle. There we go. I know what's happening. I'm drawing a circle which is so small you can't see the blooming thing. Oops, I forgot to pass in an argument here. And that needs to be pixel size divided by 2 because that's the radius rather than the diameter. Right, let's wait and see. Remember, the radius is half of the diameter. Okay, so in about 10 seconds we should see the little blob start to appear. I should have chosen an image without lots and lots of white blobs, white pixels at the top. But I think it's beginning to draw that grayscale image. I wish Turtle Graphics was faster. We could optimize this using a different drawing package, but the whole purpose of this season is to get you familiar with two-dimensional data structures and, and Turtle Graphics itself. So next week, we're going to work with actual RGB colors rather than grayscale. But I hope that this has been useful practice in how to load from a file and then how to iterate through a two-dimensional data structure to actually draw.